Okay, lesson 9.7 is titled Factor Special Products. We're going to be factoring perfect square trinomials and binomials that have a difference of two squares pattern to them. So let's just first define perfect square trinomial. These are trinomials of the form a squared plus 2ab plus b squared, and a squared minus 2ab plus b squared. Those should look familiar. We worked with them in lesson 9.3. Those were the trinomials that were the result of doing things like multiplying a quantity x plus 2 squared, so multiplying x plus 2 times itself, or multiplying r minus 7 squared. So they are what we call perfect square trinomials because they are the result of squaring a binomial of some sort. We also worked with binomials that resulted in, or that were the result of multiplying two factors and resulted in something that has the pattern, the difference of two squares. Those were the type where we would take something like a plus 2 and multiply it by a minus 2. So we're not really squaring, but the terms in both binomials are the same, and so we had this special pattern. So these were the ones where the middle terms canceled each other out. So for example, if I FOIL this one, we end up with a squared plus negative 2a plus positive 2a plus negative 4. So negative 2a and positive 2a canceled each other out, and we ended up with something like this, a squared minus 4. What you're seeing is what we call the difference of two squares. Difference of two squares. A squared is a perfect square, 4 is a perfect square. So in this box here, we're just defining that algebraically and then seeing a numerical example. So the difference of these two squares would have been the result of multiplying a plus b times a minus b. This is an example of this pattern. We have 9x squared, which is a perfect square. 9 is a perfect square, x squared is a perfect square, and of course 4 is a perfect square. And this is the difference of those two squares. I'm just going to kind of skip this, but that would have been the result of multiplying 3x by itself, and then it's the sum and difference pattern. So plus the square root of 4, which is 2, minus 2. So this, multiplying this is the sum and difference pattern. We called it back in lesson 9.3. Now we're just kind of undoing that multiplication and finding the factors that led to the difference of two squares. Let's look at a couple of real examples here. What I've done is I've covered up the notation that originally is in the note-taking guide. I'm just going to show you some shorter ways to do it rather than what they show in the book. It just gets confusing with all the notation. What we're looking at in this example is we're factoring the differences of two squares. So we're not trying to solve right now, we're just factoring polynomials. So if we look at this first example, you can see it's a difference of two squares, two perfect squares, z squared and 81, which means it was the result of the sum and difference pattern. So we think about the factors are going to look like this. There's going to be a sum, and there's going to be a difference. And then z squared was the result of multiplying z by itself, or squaring z. 81 was the result of multiplying 9 times 9. And of course, the middle terms would have canceled each other out because we would have had positive 9z, negative 9z, and positive 9z. So the resulting binomial is z squared minus 81, which is the difference of two squares. Example B, same idea. This is the difference of two squares. So I know it was the result of multiplying the sum and difference pattern. So a sum and a difference. Square root of 16x squared would be 4x. Square root of 9, of course, is 3. And the middle two terms would cancel each other out. We would have negative 12x and positive 12x. So those aren't part of the resulting product. Here's another one, the difference of two squares. So it was the result of multiplying these factors, the sum and difference pattern. Square root of a squared is a. Square root of 25b squared would be 5b. So we're seeing our old friend, the sum and difference pattern. One more time, the difference of two squares. So this is the result, it was the result of a multiplication of the sum and difference pattern. Square root of 4 is 2. Square root of 16n squared is 4n. So your knowledge of the sum and difference pattern is pretty crucial here. So if that's something you need to refresh, you could look back at lesson 9.3 in your note-taking guide. So we have 4 checkpoints here that you could practice, that I want you to practice, and tomorrow we'll compare and discuss your results in class.